Welcome back to Demystify Sci. I'm Anastasia,
I'm Shiloh.
and today we are talking about what it would look like to actually have a functional science.
Institutionally speaking.
Institutionally speaking, to some degree, for sure, but also, are institutions necessary? Is science an institution? What are the things that make institutions die, and how can they be revamped or revitalized into something that's functional into the future? And we've had a bunch of these conversations. I would say that we probably talked to Jim Keller about institutional birth, death, and decay.
Samaburia.
Ben Landau Taylor. So good.
No, I just jinxed you on that. Ben Landau Taylor.
And it's just this thing that happens to be in the background of a lot of conversations, because if you've stuck around here for long enough, you know that we're sort of skeptical about the ability of current scientific institutions to be able to provide the kinds of knowledge advancements that are necessary to power us through the next 50 to 100 years. I'm not really quite willing to accept that the sun has set upon whatever you want to call the culture that we inhabit, but I think that if the sun is to not set, that we have to figure out ways to make the institutions that have been around for the last 400 years still function for us, and science is at the center of that. And so with us, we have Geoff Anders, who is the leader of an organization called Leverage Research, who has put a lot of effort into figuring out a cohesive story of the history of science. And he's also involved with one of our other guests, Clarissa Yellow, on her quantum biology initiative, and is kind of also in the crypto world and trying to figure out alternative ways to be able to fund scientific projects that are happening on the outside of institutions.
And govern them. I think that's what we're going to find. We haven't had this conversation yet, so we don't totally understand, but I think they're trying to use crypto architecture to basically set up the administration of the program and how decisions are made.
Yeah, exactly. And so it's basically a group of people that are trying to do something that's kind of audacious and well outside of the context of the way that we normally think and talk about science, which is academia. And so I don't think I really need to belabor the point. I think it's a really interesting conversation. We left off on a really interesting point, which is, okay, well, we've talked for almost 3 hours about how to make science go faster and how to make science work better. And it's like, okay, well, how good do we want it to work? Is it a terrible idea to have a science that's really, really effective at creating new technologies that screw with our psychology and our society? Or is it best to figure out how to have a really effective science and then also figure out how to apply really good brakes to it so that we're producing new technologies at a rate that we can actually integrate them into society without breaking everything? And we don't answer that question. We just walk right up to the edge of that and then call it a day. But if you guys enjoy the conversation and you tell us in the comments and you tell us what other directions you want us to explore, we'll have Geoff back and we'll be able to actually dig into the subject of just how far and fast do we go.
Yeah, he also has a bunch of research on his website about, I think it's the psychology of belief structures, something like related to that. I really wanted to talk to him about it. We didn't get to it. So I hope we do get to talk to him again. Remember, guys, podcast is entirely paid for by you guys, the listeners. We don't have any ads other than the ones YouTube slaps on there automatically. We don't sell any products to you that other people make. We're generally committed to making this a Renaissance project where we're paid for directly by patrons. So if you have the smallest amount of money to spare every month and you enjoy the show, you find yourself listening to it often, consider coming over to patreon.com. Check out what we got going on over there. It's a pretty cool group too. You know, we get together once a week over Zoom. We hang out, chop it up about all of our favorite subjects. We've started having some podcast guests come by, so that's a pretty cool little perk. And you get access to the episodes early, but most importantly, you can rest assured that you are making sure that this is not a project where we are trying to sell stuff. It is just a project that we are trying to bring you the edge of what's known in all of these different disciplines. And we're chasing our curiosity, and we'd like to have you along for that ride. So check it out at patreon.com. If you don't have any money to spare today, but you might tomorrow, great. You can share the podcast with a friend. You can rate and review it. Make sure to subscribe on YouTube. Give it a thumbs up if it was a conversation you enjoyed. All these things do contribute to us ultimately being able to reach more people and get better guests and build this into a more strong project. So there's a lot you can do.
And we have a really exciting announcement to make. If you've been listening to the podcast for a while, you probably know that we are all about exploring the theories that challenge our conventional understanding of the world. You'll also have heard us and our guests talking endlessly about how difficult it is for the Academy to embrace these often far-out ideas, even in the face of an imminent paradigm failure.
For example, everybody sort of realizes the data streaming out of the James Webb Telescope has kind of pulled the rug out from under the standard model of cosmology. But instead of calling for a new theory, most academics remain hard at work on paradigm repair. Almost all serious alternatives can only find an audience on the fringes. There seems to be no institutional space for a conversation between those two camps.
We believe that a healthier scientific society would include both of these perspectives and more, which is why we're bringing together Alexander Unzicker of Unzicker's Real Physics, Eric Lerner of The Big Bang Never Happened, Gareth Samuel of See the Pattern, Dr. Mike McCullough of Quantized Inertia, Dr. Andrei Kokatoris Assis of the University of Campinas, Dr. C.S. Unikrishnan of the Tata Institute of Technology, Dr. Indranil Banik of the University of Portsmouth, and others to discuss what lies beyond the Big Bang and the crisis in cosmology.
So this June 12th to 16th, DEMYSTICON will meet in Sesimbra, Portugal at a gorgeous seaside hotel for a long weekend, talks, panels, discussions, and mingling. Space is going to be pretty limited, but we really hope you will join us. So check out the links in the description or visit demystifysci.com for more.
Keep that in mind. For now, enjoy the conversation with Geoff Anders, enjoy our exploration of the history of science, and we will see you next time.
The scientific revolution starts now.
The DEMYSTICIZE podcast.
Let us see in the dark.
Do you guys know Sama Borya? Have you talked to him yet?
Mm-hmm.
We did talk to him, but we completely fucked up the audio for that conversation. I forget what exactly happened.
It was that the video somehow froze towards the end of the conversation, so we still had the
I think
audio.
we didn't have the computer plugged in.
It
was something retarded, yeah. But yeah, we did. It was fun to talk to him, but we kind of screwed up that recording. So.
And we just released an episode with Ben Landau Taylor.
Oh yeah. Both of them used to work for me.
Ah, interesting.
What's Samo up to these days? You guys in touch still?
Yeah. He runs Bismarck Analysis. That's where Ben works. And he's working on creating an atlas of all the world's players and institutions.
That's cool. What exactly does Bismarck do, by the way? I've never really understood that.
They do contract work for clients who want to understand some aspect of the political landscape better and construe political broadly. So like maybe you want to understand philanthropic giving better. Like who are the players? What are they doing? Etc. He's super good at that. And then
Why would you want to understand that? Is this like market maneuvering and stuff, or like
you could think of it as if you want to understand your market, but you want to go a bit deeper on the analysis, and then probably you'd contract Samo if you agree with some of his major claims or major theses. He thinks that it really matters how functional institutions are. This is why I mentioned him, because he said all institutions die, and I'm like, maybe. But he also has this thesis about live players, where the idea is that knowing who is essentially an inventive or agentic person in terms of the landscape power will give you a lot of information about what's going to happen.
Interesting.
I think everybody is really preoccupied with being able to predict the future, right? Because if you can predict the future, you can put yourself in the right position to be able to be one of the people who wins instead of loses. Because, if you're some guy who's manufacturing windmills, I always think about this, like windmill manufacturers used to be one of the main money-making operations on the frontier, because everybody dug wells, and in order to not have to be able to dig or to pump the water by hand, they had windmills. And then within, I don't know, maybe 50 years of the frontier becoming populated and windmills being really big sellers, everything was electrified. And so you didn't need windmills anymore. And so now windmills have, like the yard windmills have turned into these just tchotchkes. And so if somebody was around at the windmill company and was like, hey, we should just pivot to making pumps or something.
Yeah.
They might still exist.
Yeah. If it, like a good example nowadays is AI. It's like, should you jump in? Should you invest? Should you buy a bunker? Right. For that, you want to understand the technology. You want to understand the players. Bismarck's a good place to go for that.
Interesting. I mean, that topic of the lives and deaths of institutions and, you know, how dependable any institution is in the long run is something we've explored a bunch. We talked to, do you know Jim Keller? He runs a bunch of startups in the Bay Area.
Yeah.
We had a conversation about that because he kind of has a theory that institutions have this really parallel life cycle to human beings and kind of a similar trajectory where you spend like, you know, your 20s and 30s getting like figuring out how to do something. And then, you know, the next decade, you actually put it into practice, next 2 decades, and then you kind of retire, like just kind of lean back on that for the last portion of your life. And do you think that institutions can be immortal though?
I think so. We obviously haven't seen one yet. The longest lived currently existing institutions, the Catholic Church, famously, they've had problems recently. They're still immensely powerful and influential. I think so. I'm not totally sure, but I don't really want to give up hope until I see a proof. that institutions have an advantage over human biology. Happy we could talk about that too, because I'm interested in the longevity question. But with institutions, you replace people. It's like replacing parts over the course of time. This is one of the things that Samo highlights is the succession problem. If you can figure out
Theseus.
If you can, yeah, but there's like this key part, which is who's piloting it. And so if you can get the captain, if you can replace the captain properly, and you can replace them in a way that they can solve the same problem, then maybe you could keep the thing going indefinitely.
There's like the weird innovation crisis too, which is these corporations are often rocketed into the stratosphere on the basis of some singular genius idea, right? Like Apple is a great example. Even Google to some extent, but then the bigger the company becomes to meet its demands, the less flexibility it has in terms of encouraging innovation, and you just kind of get this slow stagnation.
Yeah, it's certainly what seems to happen most of the time. I assume we're not recording yet. Are we recording yet?
Oh, we've been recording since the beginning. Yeah,
we are. All right,
yeah, we're rolling.
All right. Well,
welcome.
Happy to talk about any of whatever you guys are interested in.
Okay, so we'll check it out. I think that this question of institutions is deeply related to the philosophy and history of science conversation that we're going to have, at least in my mind. And so to connect it more explicitly, the question is, do you treat science as an institution?
That's a great question. I've just been rereading Kuhn's Structure of Scientific Revolutions and thinking about this and related questions. I think I do think of science as an institution. I think about institutions as having been founded, created by some number of people. So it's weird to think about science as having been created. But I do think that the Royal Society marks, as far as this, so I'm still learning. I'm learning about the history of science. I think I understand some things. I'm looking forward to understanding a lot more. But as I currently understand it, the Royal Society was the beginning of science. And I think that you can make a meaningful distinction between science and natural philosophy, which came before. So yeah, I think science is obviously, it's much larger than the Royal Society now, but I do think about science as being an institution.
What is that segregating wall between the two, natural science or natural philosophy and science?
Yeah, so people will have heard about natural philosophy. Usually it's referred to as, well, it was science before we started calling it science. But I think there's actually an important difference. The I think about philosophy as being a more individual pursuit. Obviously, you can do it in groups, but the quintessential philosopher is like thinking, and this is an activity that they're doing individually. When you look at works in natural philosophy, they're in treatise format. So they're, n 100 pages long, and they employ a huge range of different methods. You could be looking at observations, you could be doing long arguments, you could be there's all sorts of things you could be doing. And the audience for those things typically ends up then being individuals. So it's, you write your treatise, and then someday someone picks up the treatise and they read it and they're inspired or they're infuriated and they go and write something further. That's a very individual centric activity. Whereas science, as I understand it, involves a group activity where you have observations, and this is a thing that was done at the Royal Society. You have the slogan "Nullius in verba," take no one's word for it. You do an experiment, you have an instrument, you produce an observation, and everyone checks and can tell that they make the observation. The people sharing observations and then mutually checking and correcting each other, I take that to be the thing that defines science as an activity. And then that it might seem like it's a small difference from natural philosophy, but I think the difference between an individual activity and a group activity, they're in fact very different. So I think science, you get this grounding in observation, and you get it being a group activity. So I propose that's the difference.
There's something about it that because philosophy and natural philosophy, I think, can be the study and observation of concepts more than objects. Like, I feel like a lot of the natural philosophical ideas of the spirit that imbues matter and the kind of alchemical, spooky stuff that was a big part of it has to be some measure reflected in the distinction, because science all of a sudden stands up and is like, well, no, like, we start with the stuff, we start with the objects, and then we have to task ourselves with figuring out what it is that the objects are doing. And
That's the philosophy part, though, as far as I can tell. Like in every scientific paper, there's a paragraph at the end, which is very philosophical, where after everyone's agreed on the observations and the phenomenon has been, adequately inscribed or restricted, then there's this speculative phase we call the conclusion section, but it's really like I used to do this. I had to take a seminar in grad school where we would just analyze these high impact papers, and it was funny because we'd go through all of the data, and then at the end we'd read the conclusion, and the conclusion rarely aligned with what we would have concluded from just rigorously tearing apart all of the figures, and so that seems like a philosophical domain where you're actually adding this layer of interpretation, and that's where things start to depart from this consensus idea where, maybe everybody kind of agrees on the conclusions, but not everybody agrees on all the conclusions. And so you actually get this kind of individuation.
well, there is some individuation. I think you're right, but there's also a sense of what is allowed to be said and what isn't allowed to be said. So if you do an immunology paper, and it's a cell paper, you have figures 1 through 15, panels A through H in every single one that's like
you're giving me anxiety now.
that's representing some case that you're making. And you get to your conclusions and you're like, ergo, we have proved that God moves within the animal world and the immune system works by the hand of God. It's like, I don't think you could publish that.
Well, it's got to be a natural mechanism, I suppose.
I think that's a really important key difference, is that like natural philosophy has this sense of like the spheres operating, and science is this idea that it's like, no, there's something that is designated within the experimental system as being the thing that explains it. Cause and effect are terrestrial and material and observable and manipulatable.
But I think Newton, the natural philosopher, would have agreed that the mechanism has to be natural. That's what the word natural means, right? Philosophy might be in some domain of thought and like mind praxis.
Can I actually ask you guys a question then?
Let's do it.
Because there's an interesting question about what counts as natural. And you were just making a distinction with the sort of domain of thought. One field that I've studied a whole bunch is psychology. And if you go back and look at philosophers who comment on the mind, like there are a whole bunch. So there's David Hume has his theory of the order of the train of thought. Plato has the tripartite soul and has a theory of the different of the souls. The mind for Plato, you have different types of mind that then correspond to different types of city-state that you can have. And so what does that count as? Like, is that a type of natural philosophy? It always it's classified as philosophy, right? It's in a book where many different subjects are treated. But yeah, but because if you think about Plato looking at the different divisions in the mind, he makes observations, he gives arguments. It's like, you might think that you shouldn't eat the chocolate cake, but you are eating the chocolate cake. There, he doesn't use chocolate cake, but that nevertheless argues Plato, that you have different principles, different things in the mind that are, cause and effect, causing different things to happen. So you have to distinguish the rational part from the appetitive part. And then he tries to correlate those observations with observations about how cities work, or city-states. And so does that count as philosophy, natural philosophy? Does it count as science? Like what is that?
I mean, I'm not totally. I see the difference between science and philosophy that you're pointing out, which is this group activity of it. But to roll this back to natural. When I think about natural mechanisms or natural philosophy, I'm just thinking you can't point and say it's magic that it happens. You need to show me a step-by-step mechanism by which the actors pull off the actions that inscribe the phenomenon. So, I wouldn't consider most quantum physics to be naturally philosophically grounded. If you're saying that there's just some magic that happens, like it's a particle and a wave, and we're not going to deal with what that means, then you're not really doing natural philosophy anymore.
So, go ahead.
No, go ahead.
Is it okay to identify a phenomenon and then to with essentially the promissory note that you'll figure out how it works? So one thing that,
like Newton,
like Newton, initially there's no postulated mechanism of gravity. Eventually, with Einstein, we get a mechanism.
sort of.
I was thinking of, sort of. Well,
well, it's still just like a quantitative description of what's happening. It's not really a mechanism.
You don't think the bending of space counts as a mechanism?
I fucking absolutely do not. I mean, it's like,
I'm sorry, you've just wandered into like our favorite dead horse.
I mean, only because it's not like a physical theory has to have physical actors that do physical actions in order to provide an explanation for the phenomenon. So if you start warping ideas and applying physical transformations to concepts, then you're in the realm of analogy, and it might be accurate and poetic, but you're not actually giving me a natural mechanism by which something occurs. So it's like, it's okay. Like, I'm open to the idea that the universe operates through magic. Like, if you want to go down that road, just be honest about it. Like, let's not pretend that it's a natural mechanism.
I was thinking of the history of electricity, because even though people think they have mechanisms at various points, they really don't for a long time. And I think I'd be interested in, and I know you're supposed to be interviewing me, but we can sort of, how are you guys?
I mean, we try to just like, we try to like not do it. We try to do conversations more than
Right,
interviews.
okay.
Yeah.
Well, so then I would want to understand, how do you characterize magic? When I think about magic, I don't just think of mechanismlessness. The reason for this is that there's an infinite regress problems with mechanism. So if you have it be that gravity works by gravitons, then you're like, how was the graviton emitted? And if you're like, here's the equation, you're like, great, that explains the pattern by which the graviton is emitted, but how precisely is it emitted? If you go all the way down, you're going to find that for the last, the last joints in your mechanism, there won't be a mechanism. So I don't think about magic as being mechanismlessness. When I think about magic, I usually think about it as relating in an important way to the human spirit or will, where you're thinking about there's a question of, is it natural philosophy? I'll interested in your thoughts.
I think that this ties into a conversation that we've had before, me and Shiloh, about the differences between magic, myth, and mysticism,
Okay.
and the way that all three of those things play in the mind, where it's like, I view magic as being something that is inherently, there's a subterfuge there. There's someone who is the magician. Like, magic doesn't necessarily just happen. Someone is doing magic. But on the other hand, myth appears to be something that does just happen. It's something that's in the water. It's this cultural thing where by a communal decision, we take some figure or some story to be incredibly valuable. Like, Shiloh started doing this thing where he will watch a movie and then he'll start to try to figure out which Greek myths it incorporates most accurately. And I don't think there's been a single movie that we've watched where you haven't been able to pin it to a set of really, really ancient stories. And it's weird because none of us inherently walk around and are like, well, we believe in the Greek gods, and yet we're still telling the same stories, and that doesn't seem magical. It seems mythical in the Joseph Campbell sense, where there's just some way of how we relate to the world that has been maintained over the course of history with such fidelity that something like a Greek myth can still be applicable, and something like the Catholic Church can still be a good institution. Okay, so, and that's like myth. There's a powerful story. Magic feels like somebody's doing it, and mysticism feels like someone is intentionally trying to delude you into thinking that something is that isn't.
That's interesting. On the characterization of myth is, I think, cool. I want to think about that. For magic, interested in what you think about the alleged phenomenon of synchronicity. So this is a thing that Carl Jung talks about. You essentially have people experiencing surprising coincidences. You both think to call each other at the same time, even though you haven't spoken to each other in years. And then he has an explanation. There's a question of, can that be given a physical, et cetera, explanation? But that strikes me as something that seems pretty magical rather than mythical, but that there's not necessarily a caster.
Can I roll back and address something you said earlier? I do want to get to that. That's interesting also. Yeah, thank you. There's two things that you mentioned that I don't want to slip by. One is the infinite regression of theories, right? The inability to terminate. But I also wanted to point people, and I pointed this out on the podcast before, there's a fantastic paper. I think it's called 100 Years of Magic and Physics is Enough, and it's by a philosopher. That's not literally it. It's something close to that. I'll dig it up and put it in the description. And he does this really cool analogy where he's like, look, relativity is kind of like showing up to watch an illusionist on stage. and the illusionist is sawing a woman in half. And the relativists would aggregate all of the perspectives of the audience members ad infinitum, right? So you would just basically take every perspective possible and create a mathematical description of what it looked like to see this woman getting sawed in half. But the hidden reality is that the woman is inside of a box and she puts her legs up, and you can't see that. And so there's this hidden actuality of what's physically occurring. But to assert that the conclusion is that everybody sees a woman getting sawed in half, therefore the woman's getting sawed in half, is absurd, because everybody knows that that's not naturally feasible. And so to tie this back to the idea of what the hell do you do, because at the end of the day, you're limited in your observational capacity, right? You can only see so small. And I would say that the solution to that, the ingenious solution to that, is the hypothesis. And I would say that a hypothesis is basically making an assumption that you ask the audience of your work to roll with. So you're like, let's assume that there's atoms, right? But we're not going to split. We're not going to fight over it. We're just going to assume that there's atoms in this presentation, and that the atoms are these physical objects that are going to act out all of the different behaviors that we're going to ascribe in explaining this given phenomenon. So I think
I do hate to cut your legs out from under you and know this as I say this, but do you remember what last night we were talking about? Why is there stuff versus nothing? That's the gap in your explanatory power, is that even if you begin with atoms and you're like, the universe is made out of atoms, which I think is a really good starting point and a very valuable one, you then get down to the bottom of it and you're like, why the fuck are there atoms? And you don't there's no explanation for it. You just have to take it. And so
right. I just wrap it into the assumption of the hypothesis, essentially.
That's true, but
and it's like, you could prove to me that there aren't atoms, right? You could tear apart you could destroy my hypothesis. And so there's people in the academy are obsessed with hypothesis testing, right? Because, okay, if you destroy my hypothesis, then my theory falls apart.
But I think that what Geoff is saying is, and if I understand this correctly, is that each assumption that goes into a theory then demands its own mechanistic explanation. If you assume
it's a never-ending process, right?
And so you get to a place in the process of explanation where even if atom is your fundamental building block, then you're stuck at this place where you're like, well, why is there something rather than nothing? And that is a place where it breaks. And you're like, well, there has to be mechanism. But then you run into this philosophically intractable position where many, many people before us have foundered, which is, how do you explain the birth of eternity and everything?
By the way, that paper is called 111 Years of Magic. Pop up. 111 Years of Magic Are Enough. Let Us Return to Science Now by Dimitris Christopoulos. There you go.
Excellent. We'll throw it in the description. It is a very good paper. But so, like, there's a bunch of handles on this. Let's see if we can get to a place where there's one that's easy to grab onto. You, Shiloh, you were trying to pull on a couple of different threads. One about the kind of magical interpretations of quantum physics and these phenomena. Was that tied to a larger...
I think we were just started off playing with, like, what is a natural mechanism, right? And the funny thing is, too, I don't know if it's time to bring this idea into the conversation, but those mathematical descriptions that completely lack explanation whatsoever are perfectly valuable for technological progress, right? You can make, from your study with electricity, I'm sure you could comment on that, but, you have a few equations that describe how electric circuits work. Like, you don't need to know a damn thing about the atoms or what hidden processes they're doing to one another. You just need to understand how to parameterize your system in such a way that you can figure out how to make your machine work.
Okay, so is that a distinction between natural philosophy and science? Is that science is aimed at parameterization that allows for eventual application? Maybe even without
necessarily... This is something that really drives me crazy, is like, we have institutions of science and technology, but most people couldn't tell you the difference between the two if their life depended on it.
It's true. And I met you guys through Clarice Yalo, who's the preeminent scientist in quantum biology. You guys will be talking to her soon. She and I have been talking to lots and lots of people who are really passionate about science, but that when you dig, the thing that they're actually focusing on is technology with sometimes incremental scientific advances. It's very science themed, but many fewer people who are interested in science in the sort of finding a new type of causal mechanism. So yeah, I see people confusing science and technology. Well, part of the reason, I mean, if we're trying to go at the nature of science, it's like, how does science differ from natural philosophy, and how does it differ from technology? There's a way that science is or has been supposed to be in charge. It's like, when are you supposed to say yes? If people are like, this is science, then you're supposed to agree, and you're supposed to tell your friends, and and so forth. And so it's not surprising.
Trust the science.
Right. We saw that recently with the pandemic. If an abstract concept like science is declared king, then it's not very surprising to see a whole bunch of people try to get in on that. And so technology will want to cast itself as science. Lots of things will try to cast themselves as science.
So as you're saying this, I'm thinking back to the question you asked about Plato, which is, okay, so Plato's looking at the human mind and making these analogies to city-states, and I'm like, is it a treatise of political science then, in some sense, because it's being instrumentalized towards some practice in the world of either how to manage human relationships or how to manage political relationships? Because that feels very technological at the end of the day.
It is, and in fact, what I was referring to is from the Republic, which is his most famous treatise in political theory, essentially, or political philosophy, or political science. Though you could also see applications, like a lot of it involves discussion of virtue and understanding. You might think, well, I'd like to be a virtuous person. A bunch of Plato's dialogues pertain to this. And so you could look at the study of the mind or the study of human character as something that then could be a technology. Like, it could be, if we could figure out what's the formula behind virtue, then you could have mechanism. Maybe you have different pedagogical mechanisms. You can teach people, and through different teaching methods, then you could cause people to be more virtuous. In my mind, that's a technology.
Okay, so is there also some aspect of this that has to do with natural philosophy being a thing that was practiced when the other side of the coin was like religious philosophy, where it's pointed outwards inherently onto nature, like not onto humans, which are clearly theologically separate from nature?
So you think that the study of the mind and the study of political forms doesn't count as nature? And this was the question I was asking earlier, because on one hand, we're part of nature, but on another hand, like you were saying, it seems like we're different.
This is actually really funny. I have a good friend who got a PhD in romantic poetry. And I remember there was one point after we graduated where I was on the phone with her and I was trying to make this case about the fact that human society was structured along fundamental biological principles. That, like, if you were to look at bacteria and observe the principles of multicellularity, like, this is what I studied, right? I studied bacterial multicellularity, so I'm like, okay, look, you can see all of human society play out in the microbes.
Oh, that's fascinating. Huh.
And she was like, you can't do that. And I was like, what do you mean I can't do that? And she's like, you can't just say that. Like, that's a thing that's not sayable in.
Why are you not allowed to say it?
Because in the humanities, you can't draw this bio-human argument. There is still, even though it's not an explicit allegation or an explicit rule, there's the implicit idea that the weight of social movements that is behind saying that humans are like nature is social Darwinism, is eugenics, is population control. It's all of these really ugly
Sure.
things. And
Right.
so we must somehow excise ourselves from nature and not draw those parallels.
I would also say it's a useful distinction if you're trying to, in certain contexts, right, where you have, say, synthetic biological organisms that have been, so like anything that has been made by a human, it's difficult to, it's less useful to consider that natural, even though obviously human beings exist and we're a product of nature. But if you're trying to distinguish between stuff we made and stuff that everything else made, then perhaps natural, artificial are a good delineation.
Oh, that's fascinating because there's an interesting question how much humans are their own creation. And maybe this gets to your point about the, if Darwinists or social Darwinists tend to think about this as though this is like human doom in some way. It's like, well, we came from nature, red in tooth and claw, therefore human society will be equally bad. But humanity obviously has the ability to create itself to a certain degree. And so maybe it's like the coins landed on its edge with respect to, human society created by people. Maybe we think there's a question of could it have been created differently? I want to vote yes. And then we didn't create most biological organisms, only the couple that, the synthetically made ones. But then for ourselves, yeah, it's
Well, what's even crazier is like how much can you, like when I agree with you that we do seem to have a unique propensity to create our own selves, but I also then start to wonder like to what lesser extent is that a principle of nature in general? Like to what extent do other organisms do the same thing but in a less obvious fashion, right? Like this brings in that horrible dirty word will or
desire
yeah.
or like directional movement across evolutionary time towards some form. Like Shiloh, we were talking last night about the evolution of species and consciousness and the way that humans are kind of this weird eyeball onto the universe. Like it's weird that the universe made humans to then look back on itself. It's almost Narcissian in its construction. That like the universe would create a mirror for itself. And then we were kind of toying with the idea of other beings evolving. I'm like, I look around and I'm, there's trees and ants and everybody else. And is it possible to have them take over the earth and have some kind of this sounds so crazy
Or
when
just
I
on a
say it
different
out
planet
loud.
or something.
Or on a different planet, but it's like, okay, what happens if ants are not somewhere down mid-tier on the food chain, but are actually the creatures that are biggest and strongest and smartest on a planet? Do they eventually evolve to some kind of like insectoid superintelligence, the way that humans appear to be evolving towards this kind of human superintelligence? Because I'm like, you look at the way that we train superintelligence now, and it's not like we're booting into it the organizational principles of brine shrimp and ants and forests and whales. We're like, read our work and despair or whatever. And so I'm like, what would it look like to have a superintelligence that's ants-like? I think it's possible.
Ender's Game.
Right, yeah, exactly. And so I'm like, I just think that our sense of our superintelligence, our creations, our prominence is deeply informed by the way that we interact with the environment and with each other. And there are alternatives if your sensorium is different. But I think that humans are kind of locked into a path that the only way out is through. Like, I don't think you can go back in history and then hit play and then have World War II not happen. Like, I think that World War II always happens. And I think that World War III might always happen until everybody gets together and is like, okay, well, we need to have some kind of permanent way of remembering this, that we shouldn't do this. And it's not. I don't think that it's a branched path. I think that it's folded in onto itself somehow.
It's interesting. If it's not a branched path, does that mean that we're not really choosing?
So that's the crazy thing. I think that you do choose, but you choose based off of all of the inputs that you get at a given moment. And if all of the inputs are if the inputs are the same each time, then you'll make the same choice each time.
I like the fat fist delineation between strategic and tactical free will on this subject, which is like, if you're a giraffe, like you're gonna eat some leaves that are probably at a certain height or something. But you also get to choose which leaves to eat. And so there is like I have, I don't have the free will to float out of my chair right now as much as I would love to do that. But I can choose how to move my body while I'm stuck to the chair. So it's not a black and white issue necessarily.
No, but I think that this is tied back to this question of like, are humans natural or not? And
What are we if we're not natural? What are we if we're not natural?
Well, if everything that we do is synthetic, then it's hard to imagine. It's like then you come down to this like Cartesian thing of the Cartesian dualism of, where does the spirit reside in the body? If the spirit is immaterial and the body is material, you're stuck with this interface problem. And so if everything that we make is synthetic and we're not synthetic, then where does synthetic emerge? Like I think it's an almost impossible line to draw. I don't necessarily think that the things that we make are synthetic. I think that philosophically it's almost impossible to say that what humans do is synthetic and then say that humans are not synthetic. Because I'm like, where does the synthetic emerge?
Well, I mean, maybe there's the question of what people really have a choice over. So, I mean, on one side, there might be we do everything exactly the same way. On the other hand, maybe there's tactical free will. And I like to think that at least humanity seems to have the ability to make different choices about technology. You can see this in different societies. I've visited Japan a few times, and it's just fascinating that very simple example, they have vending machines that give you hot drinks in a can. And that's just, whenever I'm there, like, why has this not made it to the US? It's amazing. But Japan also has high-speed rail. So they got the bullet trains. Part of the reason they can do that is they have a different culture, different sort of way of relating to the government. If you imagine that all of the different cultures all naturally produce different technology sets, then, and we have some choice, you have to suppose, in the creation of the different cultures, then maybe we have choices over which technologies we deploy and which ones we don't. And that maybe that gives a way to anything that we can choose for ourselves or choose not to do should count as self-created. Maybe put it like that.
Okay, and that's really interesting. Anything that we can choose to do is self-created?
Yeah, you want a two-way power. You want it to be that you can choose or you can choose not. If you can choose to flip the switch, but something's moving your hand up, then you couldn't, you want it to be that you could choose yes and choose no.
Okay, so to link this back to put a handle on this, we were talking about this question of natural philosophy versus science. And I posit that natural philosophy was in context of religious philosophy as being the two main ways that you could encounter the world. And one was about everything that was outside of human nature, humankind, human behavior, and the other was very specifically about the divinity of man and our relationship to God. And then what happens is as natural philosophy starts to transition into science, you meld the religious aspect and the natural philosophical aspect together in some way. Because the science is, like you were saying earlier, a holistic worldview for how the world operates and what can be done and what ought to be done. Because like consensus kind of operates that way.
But you think that I was surprised. I thought you were going to say that the religious philosophy aspect got ejected. I mean, my experience with so Cyan, you guys will undoubtedly have talked about this in previous conversations, but you may be familiar with the idea of the multiverse, where it's proposed that all of the different possibilities exist, and we're just here in, there's a million, then there we are, number 227, and it'll be that there are way more than a million. As far as I can tell, one of the reasons, I'm not saying this is the only reason, but one of the reasons physicists have ended up with the multiverse picture is that they didn't want to consider postulating something like a creator. And a creator could be God, could be something spiritual. It also could be an AI, and we could be in a simulation. So it could go one way or another. But I've noted, I've been in conversations with scientists where their thinking seems to get confused when postulates come up that might have to interact with something outside the human realm. And so it's interesting that you propose that the religious philosophy got melded in. I would have thought that it got pushed out.
I think you can't push it out. I think that humans have a deep and desperate need for gods. God or gods, whatever you want to say. And we need to have this mythical framework. And with that mythical framework, if you remove the scaffold of an established tradition, if you basically say, hey, go ahead.
I mean, just to like convince you, I want you to finish your thought, but I just want to convince people that it does still persist deeply. And I think it's in those magical leaps, like the quantum mechanical superposition, or it's in the black hole, or it's in the exotic, unimaginable, dense material of the white dwarf, or it's in the impossible creation of everything during the Big Bang. Like or
Higgs particle, the God particle.
Well, yeah, the God equation, God particles, but also like, let's leave physics. What about biology? You have
Right.
this process, you have this force of
Right.
Darwinian evolution. And it's funny because you can literally read a biology paper, and if you just, every time they say evolution did this or evolution did that, you could just swap the word God in. And, God has a rationale, of course, in evolution, but it's still this hand of some abstraction, some abstract actor, right?
I remember I got really into origin of life research at some point, and I was reading the Woese paper that was the one that established the RNA pedigree for basically being able to map their tree of life. And I swear to God, if I remember this correctly, they called Darwin their patron saint, like explicitly.
I've noticed that groups that this happens with, atheists as well, people when they try to put all of the religious and spiritual stuff on the side, then it ends up coming in terms of flavor, and then you worry that it seeps into the theories. I agree with that.
And so I think that that's what I'm saying. I'm not saying that it was explicitly mapped onto natural philosophy in order to create some kind of unified discipline. What I'm saying is that we have this really sticky need of a cosmic significance and value system. And whether that's the multiverse, or that's black holes, or that's warped space-time, or whatever, like all of these things are simply us turning away from the fact that we have discrete myths about what we should be doing and our place in the universe, our cosmology, and we have discrete stories about the rest of nature, that we're separate from. We suddenly were like, oh my God, we're not separate from the rest of nature. We're not in a privileged position. All of this religious stuff probably isn't accurate. And so we have to now find some new vessel to talk about it. And I think that that new vessel fundamentally is science. And to bring it to the point that you were making about this moment of choice, where you have the ability to either choose to do something or not to do something. I think that the reason that the institution of science is so ragged right now is that it offers you no guidance as to which way you should choose. There's no moral valence attached to our central belief system. That's where I was trying to
Whereas, like,
get
the
to.
mythological structure, yes, it has supernatural actions and so forth, but I think, from a Jungian perspective or something, there's a solid argument to be made that if you're approaching those things from a literalist scientific standpoint, you're kind of missing the points, right? And so it's not clear that in the absence of a shared mythological background upon which we all live our lives, that we're able to orient ourselves towards what we want as a culture, as a society. And then it gets sucked up by science or whoever's claiming to be the authority on the shoulds, right? And that's kind of a disaster.
And that's interesting also because, I mean, you see in science, like the things that the people will say is that they're just pursuing truth for its own sake and they just are answering questions. But interestingly, if you're just pursuing truth for its own sake, it's not clear that that gives enough structure to the research. Like there's truths in every direction. You could research anything. And so there's this question, you talked about the, institution of science being ragged right now. I completely agree. I think it's absolutely in crisis. There's a question about why, and it's multifaceted, but I think at least one part is the lack of well-designed principled research programs. I mean, you can think about, like, science wasn't always housed primarily in academia. Before that, it was quite a different thing. Academia promises academic freedom. People can go off in roughly whatever direction they'd like. There's a really important question of whether that provides enough structure for you to get sufficiently fast scientific progress, or even to have the different people talk to each other. I've become worried that scientists we know things are specialized, but I've started to become worried that they're becoming much, much more specialized so that you won't even get enough people talking to each other. I mean, in my view, if enough people aren't talking to each other, sharing observations and engaging in mutual checking and correction, then you stop doing science and you revert to independent investigation. And this is something that I think the Royal Society, sort of calling back to the beginning of the conversation, like the Royal Society wasn't the same thing as science, but it was the house of science. It was like where science was set up. And so it's like science as an institution can be sponsored or housed in different places. And then for it to really work, well, you have to get the institution that's sponsoring it to line up with the institution of science itself.
I mean, I think you bring up a really good point about the social nature of science that most people miss the points on as well. Like, people are always, well, I wouldn't say always, but, people will come to us and be like, I have this really cool theory. How the hell do I publish it in Nature? And it's like, well, you better start by embedding yourself in a society of people who have published in Nature and learn what it's like to form a community of people that can mutually support the theory from their own investigative principles and so forth. And I think that in general, there is this myth, and I believed in it too until well into my late 20s, that if you had a brilliant idea, that was sufficient to make you the next Einstein or whatever it was, right? I've been at this in like the 10 years since, I have seen incredibly brilliant ideas put forth by people who have made themselves persona non grata in scientific circles. And as a result of that, I'm afraid that their ideas will never see the light of day. And not never, but
Right.
not in the same efficient time. Like those ideas will be rediscovered, they will play out. It's not clear those people will get credit for having those ideas in the original form. But there is something like desperately political and social about the institution of science that most people overlook and no one talks about when you go to grad school. And it's a very real and powerful driver of what the science ends up saying.
And a lot of it has to do with, I mean, there's social structures, right? The peer review, the people that sit at the journals, the editorial boards. But then there's also, when I think about the Royal Society, as far as I remember, wasn't it in some ways convened in order to show stuff to the royal family? Like, weren't they getting audiences from the Royal Society to like demonstrate things?
That's my understanding. My understanding is that they, from the royal perspective, this was like a thing you could show off. I think I'm thinking of the patron. I don't think I know for the Royal Society in particular, but for the patron model. Why do the patrons support science? Well, maybe you care about science, but you can also show your friends cool things and you get to see cool things. And so at least I think it holds generally there.
And so I think that there's something that's really important in that as well, which is that it's really fruitful when you have a crazed hobbyist that cares about nothing else in the world except for this esoteric thing that they're studying, and they're able to build interesting machines and, you know, make electrical current dance or sparks fly. Like with the experimentation on electricity, there's apocryphal stories of like one of the main guys who was involved in figuring out how electric current worked. He was living basically in I think it was called like a chapter house, where he was just supported by public money, and he was recruiting all of the people that lived there to do these experiments. They had some like little boy that they would suspend on silk strings to see if the chaff would stick to him, if they could like transmit the electrical charge between, you know, like metallic objects suspended from the ceiling. And they were figuring out like, can we use wool strings, or do we need to use cotton or silk? Or
Yeah, this is it's interesting. My researchers is studying this era right now. This is the Gray and Dufay era, and I was thinking of asking him before this call, but did not get a chance about how Gray was funded. So
I seem to remember that I can double check this, but I seem to remember that he lived, I can't remember if it was a chapter house or something else, but it was basically sinecured kind of academics. Like, they weren't really academics because they weren't at the university, but it was like philosophers and experimenters that were just like all living in this house, which seems a lot like the Silicon Valley model right now, which is you have all of these houses of people getting together to just try to do stuff. And so there's a sense that people are trying to bring this back, right? Because everybody recognizes that, okay, the institution seemed to work really well at some point. That point was a really long time ago. We went through all of this maturation, technological achievement. We've squeezed the juice from the lemon. And now the question is, well, where do we go next? And it's unclear that there's anywhere to go except for fucking around.
So the lemon here, I assume, is academia or the existing funding establishment.
Just like the existing paradigm. It could be like anything. Like, it could be like making cider, but just
no. I think this is completely right. And in terms of what to do, the thing I've been sort of astonished by is that I think there are a lot of really either good hypotheses or big discoveries that have already been made, where my favorite example right now is Stephen Wolfram. I don't know if you've had a chance to talk to him on your show, but the book looks intimidating, new kind of science. It's like this big tome. It's mostly pictures. The text is sort of big. It's way shorter than it seems. But I didn't have the opportunity to read it until just recently. And I think that, not to put too fine a point on it, he's right that he's figured out something really big. It has applications in physics and biology and possibly elsewhere. It's essentially a new paradigm. Should everyone, should everyone join? No. And has he figured out everything in physics yet? No. But that doesn't stop it from having a whole lot of value. And the thing I find so amazing about his case is that he just crushes it on credentials. He's publishing physics papers when he's 17 and super early PhD, and goes to the Institute for Advanced Study and et cetera, et cetera. He ends up, funding his thing through Mathematica, which is the software that he created. Notably now, a lot of people, when they do physics using math software, they're using the software that he wrote. And so you would think, and then he comes out with this big announcement. It's like, okay, figured something out. You would expect there to be at least really serious review and, attempts at, separating what's good from what's bad, and then uptake of the good. As far as I can tell, very, very little of that has happened. And so, but it's not just Wolfram. I mean, you'll talk to Clarice Yalo. I think she has an amazing research project in quantum biology, and that's not praise that I give lightly. I care a lot about research project design, but she's got a very good hypothesis, and if it's good in the sense that it's not accepted currently by the mainstream scientific establishment, it is very well supported by the evidence, and if it's true, it has all sorts of impacts for how we should think about, in particular, quantum physics and biology. But that's another one. I think there are all of these ideas. Actually, I just ran a workshop on revolutionary science and got a bunch of these people together. There are ideas, and they're just not being aggressively picked up. They're not even slowly being picked up by the existing institutions. So, this is, yeah.
I think that paradigm shifts are really painful. I think that goes underspoken. And I think that there's an analogy for this in all of our own personal lives, which is that, generally speaking, I think that we start off as little kids with basically no idea of how to get along with other people. We're certainly not masterpieces. And then ideally, you go through all of these crises throughout your life, right? Where you're like, and it's different for everybody. You go through these traumas, right? Maybe it's getting dumped by your first girlfriend. Maybe it's a psychedelic experience, but you start to kind of reconsider yourself at various points where you're like, damn, maybe I am kind of an asshole, or whatever it is. Like, it could be, and honestly, I at this point kind of recognize these on a daily basis to some extent, to the extent that I'm hopefully growing as a human being. But it's painful to go through that realization, right? You almost need to break first. And so with paradigms, I feel like the old paradigm has to really break in this painful way before anybody who's inside of that paradigm has any interest in stepping outside of it. And so if the people inside of, say, Wolfram's peer group think that they're getting by just fine on their old paradigm, then they have very little incentive to re-examine themselves, right? And so that's why I think with a human being, it takes like a psychedelic experience, or it takes, some tragedy often and it could be a minor tragedy on a daily basis, It takes something to really shake you up and really make you reconsider the belief structure that you have.
And I would add one other piece to that,
Please.
which is that you also have to have something to turn to that feels as satisfying as the thing that you're giving up. And the thing that we're giving, like, if we're talking about science as an institution, I like your analogy about the human transition, right? You have this like really crazy psychedelic trip. You wake up from it different. Theoretically, you wake up from it different because you saw something while you were on your trip that you were like, this is the structure that I'm going to use to replace the structure that I have right now. It's not like you were.
Well, this is why a lot of people hate weed, I think, honestly, because they're like, it makes me paranoid. I'm like, yeah, it's supposed to. Like, you're actually supposed to reconsider your situation. And that might not be good for like certain people who are already at a breaking point.
Yeah, definitely. I always think of that Curb Your Enthusiasm episode where Larry smokes weed for the first time and he just goes into the bathroom and he like for the first time recognizes what an asshole he is. And he can't really deal with it. But so yeah, like the rationalists always talk about this idea that there are these pillars to somebody's worldview, and you have to not you have to be able to let these pillars go, and you're confronted by other knowledge. And I'm like, yeah, that's not quite the full story. I think that the full story is that you have to have a sufficiently well-constructed house that you live in, that you can take a couple of the poles out without the entire thing falling down on your head. And so with an institution like science, I think that you have a house that is relatively wobbly in the sense that there's like a single central pole that holds the whole thing up. And if you walk in and you're like, we got to take that thing out, the people that are in the house are like, well, what the fuck? Like, that's the only pole that we have. The roof's going to fall down. And so if you're like, well, we're going to jack it up and we're going to replace it with these other ones, and then this is how the roof stays up, then I think people are more amenable to it. But without that, I think it's just you're asking people to embrace full chaos. And understandably, like I listen to a lot of Joe Rogan. I hear what stuff people are saying about scientists and academics in that sphere. And I'm like, you guys are like almost right. But I can see the seething discontent at the gates that the academics are like, we have to nip this in the bud.
Well, and then this is where, because I'm trying to imagine what does a psychedelic experience for academia look like or something. But there's this other problem, which is that, so I was just at a conference, I guess last week, and it was the week before anyway, somebody on stage cited a statistic drawn from a published paper that I think it was 85% of research funds are wasted. Now, that's first of all, that's a crazy idea, but let's suppose that even if it's just half. One of the things that I think is so challenging about imagining the current system reforming itself is that when you're talking, I think you're totally right that reform and change are much easier when there is a new structure to transition to. You don't need to reinvent the entire universe from scratch. You need to reinvent this one, you know, to rebuild your house from the ground up. You have to rebuild one room. But it's hard to figure out what you have. If you have, so we also had this analogy earlier of institutions as people. And so maybe they have similar life cycles. And so if you think about the institutions currently housing science as having become rigid, you think of the institution as having become bloated in some way, then it's hard to figure out what do you transition to, right? Whatever you're going to transition to, it's if it's 85% is wasted, do you transition to something that cuts that or doesn't?
Well, I mean, I think that it's hard to argue that 85% of funds given by patrons to the loopy experimenters weren't wasted. Like, you give somebody funds and they do a bunch of weird ass experiments that are poorly controlled.
It's a fair point. That's a fair point. No, I like that.
And so I'm like, oh, go ahead.
Can we, I don't know, we don't have to do this right now, but that science in the day of the Royal Academy was not done by people who were career scientists. If they were anything approximating that, like they might have spent a lot of their time on science, but they were independently wealthy. And so this post-war peer review system is pretty new, right?
This is definitely true. Interestingly, there are some people who are career scientists. If you look at Hawksbee he's the 1706 guy who isolates electricity as a source of light. He worked for the Royal Society as an experimenter. Though I guess his main profession was instrument sort of manufacturer. That's still pretty close. But you're completely right that after, and this is part of this, if you look at the graph of number of PhDs produced in the US, it goes up dramatically from 1900 to 2000. It's like 100x or some very large multiple. And so, yeah, we have a new system. And I mean, I guess the conclusion of this is just really simple. You just need to design a new system for the thing to move over to, so that it's easier for the existing system to transition.
Yeah, let's play with what that looks like, maybe.
So something that we've come across before is, do you know the work of Michael Levin?
Yeah, a little bit.
And like in broad strokes, Michael Levin's idea is that going down into each individual cell and trying to tweak molecular switches is probably not going to be the way that we're able to make large-scale reconstructions of tissue behavior. Like, you won't be able to regrow a limb by going in and tweaking each and every single little lever. His philosophy is that you have to figure out what are the conditions in which the cells want to make a new limb. And if you can change those conditions, then you get the limb. And I'm like, go ahead.
I was just going to say, I haven't looked at his work closely yet. I did read The Body Electric. I don't know if you've come across this book.
It was recently recommended to us, yeah.
Yeah.
But we have not read it yet.
I mean, I'm sort of on a hunt for all of the explanatory principles that are missing in biology. Like, we have this sort of surprising complexity in biology. This is marveling about how you feed a cat food. It's true for animals in general. You feed them fairly simple things, they produce other animals. Like, this is a completely shocking thing. We don't have computers that you give electricity to and they produce other computers. It's like, that's completely amazing. And if you look at how people normally explain things biologically, you have chemical explanations, mechanical explanations. DNA is sometimes analogized to code. But when you go in and look, we still don't really understand how a lot of the things work. And my thought as a theorist, I'm like, okay, there are missing explanatory principles here. That's why quantum biology, this is weak magnetic fields interacting with quantum effects. The bioelectricity is another interesting one. The Wolfram stuff actually ends up being another possible way to explain some things in biology. But yeah, anyway, I just wanted to mention The Body Electric, which is I think the main book people go to when they're starting to think about bioelectricity.
Yeah, I think the podcast we just put out last week, about a week ago, was with a biochemist, Michael Hughes. He's a longtime friend of the show. And he was also trying to reveal interesting, unseen ways in which water participates electrically in various information channels within cells. And that there are imaginable circuits, let's say dark matter of biology, places where we kind of put these placeholders in, like, oh yeah, there's pH things that matter, like, don't worry about it. And then you're like, wait a second, why does pH matter? And you start to really push on these things and start to arrive at these electrical processes and really come up with a wholly different approach to understanding how the proteins do what they actually do. And I think Michael actually mentioned the body electric, maybe if not in that podcast, somewhere else.
I'm pretty sure that it came up during patron chat too.
Gilbert
Everybody's
Ling
always-
too.
Yeah.
But yeah, that's something we've been meaning to get into for sure. Pardon the interruption. I just need to remind you that this program is entirely paid for by listeners over at our Patreon page, patreon.com/demystifysci, where you can join our inner crew and hang out with us once a week. Tell us what you think. Help us get oriented towards the most interesting problems in the world. And you can just sleep better knowing that you are making sure that this program happens without us having any advertisements or sponsors. I'll see you there, patreon.com/demystifysci.
The way that I see it is that there's two questions here. One is, can things go differently if you were to recreate initial conditions? And the other is, how do you go about recreating newly functional conditions after something is broken down? It's like, can you actually regenerate? And I don't know, I kind of want to leave that general. I think that I have a bunch of ideas for how it maps into stuff, but I kind of want to hear what you guys think before I drop my map.
I mean, it's a huge question. Like, I mean, just science or societies. I mean, when we were talking to Ben Landau Taylor, we had a similar thread that we were pursuing throughout the conversation, which was, once a civilization has crossed its golden age, is there a path back? And I don't know that we actually got an answer to that question.
Well, I'm like, I think that you can look at any biological system in general and ask that same question, right? Like, there's a relatively narrow fraction of species that can regenerate themselves. There's some like jellyfish that can return to a polyp state and then play out the entire arc again. And I'm like, is that just some kind of...
Those trees, those seeds that they found recently, that was crazy.
Oh yeah, they found like a bunch of seeds from Siberian permafrost from 30,000 years ago, and they planted them and they germinated and they grew a plant.
I believe it.
It'd be really funny if it was just weed seed, like some weeds that somebody had in their yard, and they just like slipped them into the...
It'll turn out that somebody has some nascent science institutions in the freezer, and we just have to thaw them out, and then we can plant them, and then they've been around since Plato's time or something. That would...
Okay, well, I think that that's one possible mechanism, right? Like spores. Like if we extend the metaphor of biological organization to both human and psychological principles, then spores are a vessel by which things weather long stretches of adverse conditions.
I think that's right. I think a disanalogy, or a reason I'd look for a different analogy than spores, is that with biological things, they have all the information somewhere inside them. At least, I'm actually not even sure that that's true. They have a lot of information that they start off with inside them. I think that I would trust Ben and Samo's understanding of the history of revitalizing institutions more than my own. I like to think I'm learning about the history of those things, but I'm trying to sort of think about institutions as such. A lot of the materials that you would want to build a functional scientific apparatus are materials that have existed at a certain point. So let me give an example. So usually when people are, controversial viewpoint, I think that it's pretty likely that more STEM education will actually decrease the quality of science. Now, this is surprising, right? Because you'd think the more you educate people in science and technology, engineering, mathematics, etc., the better science you'll get. But usually STEM trades off against the humanities. And the as far as I've been able to tell, the two ways that anyone understands science is through the history of science or through the philosophy of science. You can get some experience with it directly, but there's always a question of, are you really doing science, or are you doing something that is called science that is adjacent? But if you want to, you know, be sure you're looking at bona fide science, looking at the history is a great place. But if you're looking at the history or philosophy of science, then you're looking at the humanities. I've thought about but then, do we need new histories of science? Well, actually, I do think yes. And do we need new philosophy of science? I also think yes. But there's lots of good stuff that already exists. And so I would think that one of the big activities of trying to cause revitalization for any human institution is to learn as much as you can about the relevant topic from. It's like if you imagine, in picturesque terms, the civilization is declining, and then we have these huge aqueducts that we no longer know how to build, and we hear stories of the ancients who could do all these things that we can't do. Absolutely, you should study them, and you should also try to think on your own. But yeah, I think in the context of declining institutions, there's tons that can be learned from how those institutions used to behave.
So what is your vision of Science 2.0?
Well, so I'm realizing I've been getting closer to this over time, but I do think this conversation is causing me to realize that just a full new view needs to be articulated. And so I'm not going to be able to say an entire, disappointing, I'm not going to be able to say an entire one on the spot, but I can take a stab at it.
Yeah, let's hear it.
Yeah, I'm right there with you, man. Like this is something we think about all the time, and there are some there's a sea of possibilities, but I'm not sure which one is the proper way forward. Yeah.
So the first thing that I would note is that, so I do have to think about the point from earlier, which is, it's the 85% of scientific funding's wasted, but lots of scientific funding's supposed to be wasted. Okay, I do need to think about that. It's a good point. I still think it's going to turn out that the operation of most science is going to be much less expensive than people think. I don't know that that's going to be true absolutely entirely across the board, but I'm a big believer in the exceptional performance of certain individuals and groups. It's like if you can figure out who are the absolute top people, and you can fund those people and those people's research projects, then I think that's going to end up doing a lot. This is one of the reasons I'm working with Clarice, as far as I can tell. She's one of these people, and then here, the thing that I think is necessary, so here I'm, sort of in whatever, reserve the right to backtrack. I'm inventing here. I actually think the thing from earlier about how scientists in academia are sort of pursuing their interests, all truth is valuable, you can go in any direction. I actually think that having well-designed research projects is very, very important for driving science forward. That maybe just sounds totally obvious, but it is really different than the wisdom I frequently hear, which is just hire the, smartest people and then get out of their way and let them do whatever they want. The sort of thing, so for example, I'm thinking about whether my organization should host a conference next year on complexity in biology. This is because as far as I can tell, it's the biggest remaining visible central mystery. Like, it used to be, where did the universe come from, et cetera. And I agree, we don't have an answer yet to why is there something rather than nothing. But I don't know, we've been looking at particles for a long time and dark matter and string theory. Like people have been doing that for a while. We do just have biology. Biology is amazing. The complex, and then there's this question, do we actually have a good explanation for the complexity that we see in biology? There's a standard explanation. We mentioned, Darwin and natural selection. You guys proposed that natural selection is sort of maybe a stand-in for God. You see it doing all sorts of things. One of the cool things that seems to come out of Wolfram's research is that the optimization power of natural selection is actually not as high as people think. There's if you imagine there's like some number of generations, there's certain types of constraints, we can run simulations. And so if it turns out that natural selection is a weakly optimizing force rather than a strongly optimizing one, then there's this really interesting question. Okay, well, where does all the weird complexity come from? Wolfram's got an answer. The intelligent design people have an answer. I'm toying around with ways that maybe, the weird laws of quantum physics could help to explain some of those things. I think that you want basically, and this is sort of, applying sort of the Kuhnian idea, but trying to do it deliberately. If you have a paradigm, if the paradigm is sort of running dry, there's tons of people doing normal science, but we're not getting as much in the way of results, then the thing you want to do is you want to identify the anomalies. The anomalies are going to be the things that are the most solidly verified, least compatible things, with the least compatible with the existing system. So with quantum biology, weak magnetic field effects are the thing. You'll get to talk to Clarice about this, but essentially there are all these cases in biology where very weak magnetic fields have effects, and the only known explanation that can actually work for this is a quantum one. Scientists haven't wanted to go the quantum direction. I think that's for a bunch of social reasons. And so I think, cool, anomaly. You got weak, people will grant birds navigate using the Earth's magnetic field. That's a weak magnetic field. How does it work? No answers given. I'm like, anomaly. Okay, cool, we've got one. I think the complexity in biology is another anomaly. I think there are actually a whole bunch of these. The one that people get really weird when you talk about it for some reason is consciousness. I do think consciousness is real. I'm conscious. You guys are conscious, etc. But you mentioned consciousness in some circles and everybody becomes upset. Yeah.
In the sense that they don't think that consciousness is a thing? Because I've heard of a lot of people be like, humans are the only ones that are conscious. I've heard a lot of like crazy takes on what defines it, but I've never heard anybody get upset about the nature of consciousness being apparent.
No, it's I've encountered it in a bunch of different cases. The reason I think that it's upsetting to some people is that prima facie, you mentioned Descartes' dualism, prima facie, it's hard to mesh the idea of consciousness with the physical world. Descartes gave this really simple argument. You can imagine the physical world existing without consciousness. You can also imagine consciousness existing without the physical world. It's like the Matrix, except no Matrix. There's just no physical world. It's just your mind. And he proposes, if you can conceive of things existing, A existing without B and B existing without A, then they're distinct. Roughly, that's the argument. That argument gets repeated later, like David Chalmers, it's one of the sort of top philosophers of mind and analytic philosophy now. He gives an argument which is similar to this, and that's vexing. Like, in fact, my own journey in thinking about all these things, I used to have a it's all particles view of the world. And then I got to thinking about consciousness, and I was like, uh-oh. It's like there's this completely beautiful picture of the world with these mathematical equations, and it all works out nicely. And then there's this little string sticking out, and you're like, what's that? And people are, well, maybe you pull on it and figure out that your beautiful picture needs to change. A bunch of people want to say, no, that's not a thing, or it's not special. I think it's an anomaly. I think there are a bunch of these anomalies. Not all anomalies are fruitful or like easy to investigate. I think we could probably come up with a bunch of anomalies that are pretty hard to get information out of. The thing you really want, and I'm sort of talking about research program design as I see it, the thing you really want is you want a very tightly constrained evidential circumstance. You want it to be that you're seeing something that you're pretty sure doesn't make sense. There are some things where there could, so it's like, if, and I haven't looked at, I'm just learning about particle physics now, but it's like if the Higgs boson's larger than we think, well, I don't know. We didn't really know why the particles were supposed to be the sizes they are. There's tons of options. The really sort of you want to look at quasi paradoxes. You want to look at places where there's something that really doesn't seem to fit given everything else you know, because that shows you that you're wrong about something. If you're like, this shouldn't be possible given my assumptions, and it's possible, it follows that some of your assumptions are wrong. And so that indicates tractability. So I guess the thing I do is specify how the money gets raised. We've got ideas there. But then you identify well-designed research programs that go after the major anomalies. And it's okay if they all disagree with each other. That's actually fine. And then, while I'm speculating here, you create a research center that gives each of the different people their own area, but has them have lunch together roughly, so that then you get crosstalk between all the different research programs. And probably some other stuff, but let's start there.
How do you protect against paradigm repair programs? So we see, ample examples of anomalous findings. Let's pick on the galactic rotation problem, for example, right? And this could be seen as a refutation of the gravitational dominance in the galaxy. However, the popular approach that's emerged in the last few decades is to create a magical substance called dark matter, and then we can keep the gravitational paradigm for the galaxy together. And, if we just build nice enough detectors, we'll eventually find this stuff, right? So, and that's a really bright example that's glaring, but this is a generalizable principle, I think, which is that it's, the age of the universe is another one, right? They launched the James Webb satellite. There's all sorts of contradictions of the standard Big Bang explanation. And instead of being like, wait a second, maybe this Big Bang thing isn't actually the best way to go here, they're like, well, let's just, we can just do some stitching and, give it a little tummy tuck, and
also good. Like the structure of stars and the evolution of stars.
It's very common. It's very common.
It's just like there's constantly paradigms that we've invented that are maybe 50 to 100 years old that we're big fans of. That have
and all of your great if you're selecting for great thinkers, or I forget what you called them, but the sort of cream of the crop thinkers, they're gonna have come up inside of those paradigms, right? And unfortunately identifying the people working outside of those paradigms, those are usually the crazy people in their garages or something, right? Or the guy at the patent office or whatever it is.
Yeah, no, this is great. So a couple thoughts. So, okay. Thought number one, the repair of paradigms, it's really important to understand that this is both natural and frequently good. It's the actual evidential landscape, the data, is noisy. And so if you require perfect fit between the theory and the raw data, that's not going to happen. in almost any case. So even when the theory is correct, you should just expect that there's going to be what looks like hand waving and so forth. So you can't. There is such a thing as bad hand waving, but we can't ban all of it. It's just we need to be able to the thing you want to do. Go ahead.
I think that we need to be comfortable with the idea that you can come up with a theory that works pretty well in most cases and recognize that the way that the universe unfolds is inherently chaotic and complicated, so you will always find exceptions, even to a paradigm that seems to hold most of the time. And I think that our searches for functional paradigms have to be looked at through that lens. We're not finding the final molds that we'll hammer everything into.
Model is a good synonym for theory, don't you think? And so if you're building like a scale model of a B-52, like you could be like, well, that model sucks because the bombs don't explode. It's like, I guess, but it still does look a lot like a B-52, and there's a lot of useful features of that model at the same time, right?
Yeah, I think that the thing that we have to figure out is when somebody is trying to pull the wool over your eyes versus when somebody's like, look, it works in all of these cases and there's some that it doesn't, which means that there must be something else that's happening, and then gives that person grounds to go explore that. Right now what we have, or you called it paradigm repair?
Yeah, I did, or rehab or something like that. I don't know, I just threw that out there. I don't think that's not a term I got from anybody or anything.
Oh, no. I like the
Adding
vibes of that.
epicycles.
Yeah, exactly.
By the way, yeah, that was a really, really productive model,
For a
right?
long time.
It really does
Right.
recall the phenomenon very, very precisely.
And I think that the way that we can figure out hand waving versus this paradigm repair is when somebody is like, the fact that it doesn't fit doesn't matter or is irrelevant, versus somebody being like, well, the fact that it doesn't fit might be representative of something else, but the thing that I'm trying to make the case for still holds.
So I have a different sort of proposal. The thing that I worry about just with tests like the one you're suggesting is that if those get institutionalized, they're very, very easy for people to game. People can, if they learn that, saying, there are no exceptions is not the way to get funded. If the thing they need to say is, well, look, there's exceptions, that's fine, but it works in these cases. I think the thing we want is, I do think that people falsifying data is very bad, and there are a bunch of different ways I've been thinking about how one can go about essentially catching people that do that sort of thing. But on the sort of constructive side, the thing I've actually been thinking about is whether there's, rather than stopping the people from saving the appearances within their own paradigm, figuring out how to get competing paradigms identified and advanced. The problem that ends up happening in a bunch of cases is that the reigning paradigm gets a lot of funding, so it gets a lot of ability to repair itself. The competing paradigm, it is some guy in their garage, and and then they frequently don't end up having the resources to actually turn it into a real competitor. There is the challenge of how do you pick out the promising people from the crazy people, but let's bracket that one for a second. If you assume that you actually have picked out the promising people, then, and I still don't know if this works, so I'm actively thinking about this and want to do this if I can. I'd love to pit paradigms against each other where they get some amount of resources to be able to each develop, but then either the people inside the paradigms or whoever is running the whole thing works hard to identify crucial experiments that could conceivably decide between them. And so it's like each side gets the opportunity to build up, and you identify the crucial experiment, and then that helps to show whether one or the other ends up working. And you could imagine like a scientist doing this in their own mind. They like have different competing hypotheses, they do experiments, but it's hard for like scientists need to spend a lot of time thinking about particular hypotheses. It's hard to build out the other side. I actually have, I'll go ahead. I'll give an example though. I've got an example I've been thinking about.
Yeah, go ahead. I was going to give examples upon examples as well.
Well,
because there is a fracture point too. There is a fracture point. I want to hear your example though, because there's an issue with that too that I could see.
Okay, yeah. So obviously, love more ideas on how to make these things work. The one I've been most interested in, mostly because I've been spending so much time thinking about quantum biology, is quantum biology and nanotechnology, where so there's this famous Feynman lecture entitled "There's Plenty of Room at the Bottom," where he talks about this vision of, well, maybe if you got your manufacturing really good, you could make extremely small machines, all those nano machines. Maybe you could make nano machines that can make nano machines. And then this vision was advanced by Eric Drexler in particular. And so then you have a whole bunch of people who think that this is a good idea and could work. And the thing we have to do is figure out not just IBM spelling out IBM with little atoms, but figure out how to make little robots essentially that can manufacture other things and etc. So that's nanotechnology. The reason I've been thinking about that in the context of quantum biology is that, as far as I can tell, the nanotechnology sort of approach assumes that, and this is from what I've seen so far, it looks like it needs the quantum element to factor out at a certain point. So we believe that the quantum element factors out by the time you get to large objects like human-sized objects. We don't walk around seeing superpositions, or if we do, we don't know that that's what's happening. And then I was glancing through a nanotechnology book and looked at the number of mentions of quantum dynamics, and it was very like one mention or something like that. Now, I think that the semiconductor industry has to deal with deviations from classical predictions all the time. As they get down and build the tiny, tiny little circuits, they end up finding that the materials don't behave the way you would expect on the classical view. And that's because the quantum view is the quantum thing. That's what's happening. But so then if you imagine that as you zoom in, as you go down, you eventually start to hit quantum distortions. There's a question about whether the quantum distortions kick in at a high enough level or strongly enough that it makes it actually really hard to build your nano machines. We can easily imagine a world where it's not a problem. Quantum effects kick in at the nanometer level and not higher, and they factor out pretty cleanly, so don't have things dip below that. You can also imagine one where quantum effects start to come in at the 40 nanometer level, and that they become more and more intense, such that in reality you try to build your little nanobot and the nanobot's going to have a bad time. This is an example where this is thinking about quantum biology and the expectations of the nanotechnology area. I currently think there is actually a conflict here and that this could actually be resolved. And so this is the sort of thing I'm imagining where you have different approaches and then you get some different crucial experiments. And then, it doesn't if you could, there's going to be an argument the other way, which is if you can build the nano machines, then it's really hard to get relevant quantum effects that end up impacting biology in different ways. I'm not sure yet that works, but it might. And then the idea of having those pit against one another and with these crucial experiments, I think is just at least a very cool idea.
What are the paradigms that are pitted against one another?
I was going to ask the exact same question.
You said what other ones?
No, like
what
in
are
this
the
example.
Yeah, because we were talking about pitting paradigms against one another.
Yeah. So it's a certain type of classical chemistry paradigm versus the Clarice quantum biology paradigm. The classical chemistry paradigm has various assumptions about how you should be able to build nanomachines, and the quantum biology paradigm thinks it's much less likely. And so, and I wonder, I'm not.
Is there an approach? Do the quantum people have an approach to building these nanobots? Or
It sounds like they might just be saying
just
that
have a
things get
criticism.
so weird and fuzzy down at a certain scale that it's not manipulable in the same transparently straightforward way.
There's like a totally coin on edge, wishy-washy world we could imagine where there are substantial quantum effects, but we can engineer around them, but it's really hard to engineer around them, but we still can. And then you can go to either side of that. It could be that, nope, you can't, and we're not going to be able to build nanomachines. Or you could imagine something that's like less extreme, which is, sure, you could build nanomachines, but you have to imitate biology really closely, because biology is actually made of nanomachines in a bunch of ways. And so there is something special that biology has figured out how to do with quantum, and you have to do that.
As opposed to treating it like a computer or something like that.
Yeah, that's right.
I see. I mean, one of the things that I thought about earlier when you were talking about pitting paradigms against one another is that, unfortunately, I think history will reveal, and it might be more obvious 1,000 years from now than right now, but I think that history reveals that we do adopt the lesser, like paradigms do get pitted against one another, but oftentimes the one that wins out only wins out because its opponent is unable to answer some critical question which is put in front of it. Like there's a number of these I can point to that are kind of unfolding right now in the I work in the astrophysical space, so that's kind of what comes to my mind. But there's the famous Wegener-Carey debate, which is like how the continents moved apart over time. And another one would be...
Which, hold on, to make that explicit, Wegener is a continental drift, that they were once part of Pangaea and then they moved apart. Sam Warren-Carey is expansionist, where he says that the Earth is smaller and then expands in order to move the continents apart, which explains why the seafloors are only 200 million years old and like all these other things.
Yeah, let's just stick with that. Let's not even bring more examples. Yeah.
The problem with Carey's theory is that to this day, no one's been able to figure out where the extra mass for expansion would come from. There's no motive. Like, if you're like, okay, fine, expansion addresses all of these things. There's a lot, there's missing pieces of the prehistoric plate. Like, there's this ancient ocean called the Tethys Sea that nobody can find, and they're like, oh, it's been subducted. That's why it's gone.
It gets even worse, though, because the reason I think that Carey's idea, Carey didn't have a mechanism, like Nastia said, for the expansion, but Wegener actually was kind of a fringe scientist in his day. I don't know that he lived to see his continental drift thing be accepted, but anyways, it was accepted, and the reason it was accepted is because somebody, couldn't tell you who, proposed that there was these conveyor belts of magma under the crust, which provided the motive power.
They mapped the seafloor, and they found these spreading ridges, and they were like, it's like a convection cell.
Problem is that all attempts to locate these convection cells in
the locations where they're supposed to be.
Yeah, they're not there. And in fact, it gets... and actually,
I'm going to have to look into this. This is, oh no. All right, fine.
I mean, I could just spend the whole rest of this podcast telling you examples like this, where it's like, I think that maybe Carey didn't have the full idea and he didn't really understand what was happening, but he seems to have perhaps been on to something kind of interesting that never got developed. And I can just point to example. There's tons of these, and it would just take too much time for me to go into each one of these, but where somebody didn't have the fully right idea, but some other paradigm that seems to have been even less successful has become the dominant one. And so there's
Okay.
these paradigm wars that do happen, and the winner by consensus does emerge. But
Well, I've got some thoughts about, so this is great examples though. This is helping to put, help forcing me to make, revise and make my ideas better or proposals better. The So I've been thinking about, the first thought is that you don't want to have the winning paradigm, so to speak. You don't want that to be judged on something like an absolute standard of correctness or with respect to final physics. We don't know necessarily what that's going to be. We have rejected Newton because he had gravity without having a mechanism. The answer is no. We want to have accepted Newton at the time. So I do think there is going to be a crucial question of how you decide the things. The way I've been thinking about it has actually been and this may not end up generalizing to cover all the areas. I do think the continental drift area is a super good one for me to learn about and think about. But I've been thinking about tying it to existing technological research programs like one of the examples that I think is really interesting is AI. There are a bunch of people who've gotten a lot of news over the last couple of years thinking that AI is going to destroy the world. I happen to think that it's not correct. It's not going to. But I've been spending a bunch of time trying to understand how exactly that sort of viewpoint or paradigm came about. Also, if you look at the AI companies, there's actually a really large amount of money that's being spent on, you could call it a particular viewpoint or paradigm around the idea of intelligence. It's like there's all of these assumptions about we're going to get artificial general intelligence. There's assumptions about how human intelligence works, about how that's going to be replicated. I think that I'm not totally sure, but my intuition or my hunch is that if you start with areas in technology that people are trying to develop and you reverse engineer from those or trace those back to the paradigms, then you're going to find things that there are actually already people currently invested in where there's going to be some practical outcome that can be tied to some sort of difference of scientific hypothesis. And if that ends up being true, then the thing you're checking is something like the near term prospects for the paradigm as believed by the people who are advancing the technology. And then conceivably, if you can, you could save a whole bunch of money on research dead ends. There's a lot of interest in it already. And the problem's, I think, much more constrained. I'll know once I've made up a set of whatever brackets that have, the different fields set against each other. And I'm still thinking about whether even the quantum bio versus nanotechnology one works.
I think that the quantum one actually works for me most clearly in a very different way. Like, we have made our first foray into quantum computing conversations. And
Oh, yeah.
so we got a Yale professor who studies quantum computing, who designed one of the first like hardware quantum computers
I think he also came up with like the essential operating topology.
to come on the show. He's a fundamental physicist, a theoretician, and we're like, can you explain to us the Stern-Gerlach experiment? And can you explain it to us in a way that, like, tip to tail, where we're able to run through all of the possible different explanations, right? Because they're at this point where they're like, the thing that we're stuck on is error correction. And error correction is at the atomic scale. And so they have these atoms that they have held in place with lasers or whatever photo tweezers they're using. And then things are breaking because the quantum computer goes from being a quantum computer to suddenly no longer being entangled, to suddenly being, like, it just behaves in this weird way. And so I'm like, okay, I think that you have to make sure that your paradigm for understanding the atoms is really, really good. Because
or at least spin. I think that, I mean, Stern-Gerlach, for everybody who's listening, if you don't know this, is essentially the definition of this it's where this idea of superposition comes from experimentally, which is showing that there's this quantized property called spin, which doesn't behave how the theorists expected it to behave originally.
So the experiment is set up in such a way that they have a vacuum chamber with a piece of silver in it. They evaporate and heat. They evacuate the chamber and heat the silver until they get a gas of silver atoms, and then they organize them by passing them through a couple of different pores and then through a magnetic field. And classically, you should expect that as you pass them through the magnetic field, that you get this smear of atoms on the back wall that is basically representative of the shape of the spray of atoms as they come into your magnetic field. What they get, obviously, is they get a bimodal distribution where everything is either spin up or spin down. And so this is foundationally the qubit, which is that you have an atom that is either in a superposition state or it's in spin up or spin down. And so you're resolving it based off of how its superposition state is read. And we're talking to him and we're like, well, hold on a second. Doesn't the Stern-Gerlach experiment make sense if you're treating each atom as like a little bar magnet that's tumbling when you throw it into the magnetic field? And so it's either based off of the angular momentum of the atom, you're never going to see anything that goes straight. You're going to see things that either go up or down because they're little tiny bar magnets. And it was really weird because you could tell that it like was necessary for him for there to be some kind of spooky superposition that was occurring.
Oh, weird.
As opposed,
no.
He was like, the atom is like a gyroscope. You can model it as a gyroscope. And so it's, the angular momentum doesn't matter because when you throw it into the field, the axis will precess, but it won't tumble relative to it. And then Shiloh was like, but what about spin?
Well, it's like spin isn't gyroscopic fundamentally. Like it has this weird symmetry, right, that requires like essentially complex mathematics, spinor notation from Dirac's treatment. And the result is that you have a rotation that has 720 degree symmetry, which is very difficult to model as a simple wheel on a bar.
And the point is this, that like this appears to be the place. What is it?
I was going to say, he kind of gaslit me about it, though.
He did a little bit.
It was kind of like, no, they're basically like...
gyroscopes.
Yeah, they're basically gyroscopes. And I'm like, okay. Like,
See, I've encountered this. I've encountered cases where I think one of the things that, as, you know, sort of I feel like we're, you know, looking at the systems and forming like a revolutionary force to help like bring science back into alignment. I've found that scientists use metaphors that are misleading to explain things. And then you need to have enough technical knowledge to be able to point out that the thing they said is not actually literally true or doesn't make sense. And then once you do that, they like go back and they're like, okay, well, actually there's this problem here. And so like, this is the search for the anomalies.
yeah.
I think a bunch of the anomalies are being hidden by the metaphors and sort of thought aids that the researchers are using combined with popularization. It's that they use it as part of their thinking in a way where they're not screwing with the math, but then when they explain it to people, the analogy is supposed to hold literally. And then if you know enough, you can push back and say, so wait, is it, I mean, yeah, how does spin actually work? And then they're like, okay, well, you know, we don't really know, you know.
But it's even worse because you're like, yeah, I know we don't really know, but like, shouldn't we figure that out? Like,
Well,
because if we did,
yes.
maybe we wouldn't be left with this magical superposition stuff. Maybe we would actually understand that the atoms are in this whatever state of motion, their surfaces are doing whatever they're doing. And then we can actually have like heightened predictive ability. Like when it comes to designing these tools, like now it's not just this like statistical smear. It's like, oh, okay, hold on. The atoms over here are oriented this way. Their motion is doing, you know, you actually can get to that level. But as long as you're pretending like that's not a mystery. It's just kind of a tragedy.
I 100%. This has got to be. I think people should just do this in like regular. The challenge is that if you, I've been able to do this in some conversations about quantum physics because I know the philosophy side, not because I know the physics side. So if they say something about the many worlds interpretation that's not actually literally true, then I can say, wait. But I think that, yeah, the practice of covering over an actual gap in scientific understanding with a nice explanation, that has to stop. We have to be able to see where the anomalies are.
Well, I mean, there's a generational thing about this too, right? Because as a student, you're fed these analogies, and honestly, you're too busy as a student with the rest of life and all of your projects and everything to really stop and reconsider these foundations. I think that there's very little time aside from the guy in his garage for people who are already working inside of these systems to stop and really ask questions like, wait a second, shouldn't we actually understand this spin thing?
Which is why taking the technological approach to it is so valuable, because the way that I've always constructed this is I'm like, okay, well, the paradigm that wins is the one that does something useful. Like, you have a mess of paradigms, one of them will eventually build the steam engine, and then you're off to the races because you have everything that follows. But if you have somebody that's trying to build the steam engine and they're like, fuck, we can't figure out this part, like it doesn't make any sense or it's breaking all the time, and then you're like, okay, we need somebody who can figure out this part, and then you fund based off of that, then all of a sudden you don't have to have somebody come up with the theory and then make a bunch of predictions and then build a machine. Like, you're spreading out the labor of figuring out what actually is amongst the people that are actually more intuitively aligned with it. Like, Shiloh's always talking about this, where he's like, God, it probably would be better if science was organized where there was somebody who was coming up with the experiments that should be done, somebody that was collecting the data, and somebody else that was analyzing the data. And then maybe like another person who's like telling the story of what all this
From like,
means.
if you want to make it an institution that's all vertically integrated.
Sure,
Yeah.
sure.
I mean, this occurred to me like starkly when I worked in cancer research, because like I started off, like before I even went to grad school, I was working in all these labs. And like that translation of cancer research into actually useful medicines is abysmal. I'm not saying it doesn't work sometimes, it does. But the success stories are really, really few and far in between compared to how much work is going on. And it's because people need that R01, you know, they're willing to like kind of look at their data like, it's got an effect. You know, we just do 200 more mice in this experiment, like that p-value will pop open a little bit, and like all of a sudden, like here's the prompt, you know, we can, and it's like, I get it. Like, I understand. Like, you got
I'd be hack all the time.
no, but no, not that. I mean, I've literally the first time like my little heart was broken when I got into all this was I was just like a little lab grunt right after college working in a lab, and I got invited to go and visit the statisticians in their lofty office, you know, in this other building. It was fun because I got to get out of lab for a day and like go to this meeting at this big fancy table and everything. And like the conclusion of the statisticians was like, yeah, you just need more numbers in order to make this results impactful. And it was like just such an obvious case for me where I'm like, wait a second, like this is how we're going to move forward with our understanding of this system, is just to show that it's more important than it appears to be at this point in time.
So, like, to take the same cancer paradigm, imagine that the way that we approached the treatment of cancer was not, okay, we have a bunch of labs and everybody's pumping out small molecule inhibitors and we're going to screen all of them in mice and we're going to work our way to maybe 1 out of 1,000,000 that's a hit, and we'll be able to decrease the mortality rate of cancer by, 10% in a small population of Southeast Asian women of Israeli descent. Okay, great. What if we figured out, okay, well, these are people who are diagnosed with cancer and these are the interventions that they do, and this is what appears to their cancers go away, right?
Mm-hmm.
Because you hear stories about this.
Yeah, I mean, in cases where, I think you're talking about things that are considered to be anomalous, and that, yeah. So no, look, I'm 100% in favor of investigating those things. I think that there's a tricky thing with tying it to what's useful. I think you ultimately want the things to be useful, but a lot of the developments end up, so like with electricity. Electricity is a great example. 1600, William Gilbert figures out that he thinks everything's a magnet, roughly, is the one who discovers the Earth's magnetic field. But when you rub amber, it attracts leaves and chaff, and he's like, that's not magnetism, that's some other thing. Let's call it electricity. Okay, cool. Electricity discovered. This does not end up being particularly useful until you get to electric light, and now we have computers. And so several hundred years on, the thing ends up being, no pun intended, shockingly useful. But it's really, really hard to see how you could foresee any of that. Like, you have to go from static electric attraction to conduction to, actually having, wires and batteries and light and so forth. I think that this is why I think that there's two things. You want to have whoever is helping to run the, or manage whatever new institutions of science come into existence. I think you want them to have some scientific knowledge themselves. I think you want them to be trained in philosophy so that they can think very logically about relevant things and imagine different possibilities. But I think we also want to start breaking down the barrier between the technical experts and everyone else. This is sort of continuing on the idea of, well, sometimes the experts are hiding uncertainties or mysteries underneath analogies of different types. So I've been learning about quantum biology for the last year and a half, and usually quantum physics, it's like so, intimidating. It's, people say, if you think you understand quantum physics, then you don't. And that person's a famous quantum physicist. And so what are you supposed to do? One of the things that I've been doing, working with Clarice Yalo, is working to figure out how to explain the things in a way that does not mislead, does not introduce inaccuracy, but is also understandable by regular people. And so far, I found that this is a feasible thing to do. I think that here's a theory that maybe fits some data points. I don't fully know if it's true, but we think about the history of research. You've got people who want to study the stars and study the mysteries of the universe. But how do they fund themselves? Well, they have a bunch of knowledge they could teach your children. Okay, so you have the astronomer who funds their research through education. You'll note that matches how funding works with universities today. You have the smart, learned researchers who study the universe, and then they also educate your children. Well, there's a sort of a bit of a possibility of perverse incentives here, where if you really manage to transmit the knowledge, then you might not have as much of a product to sell anymore. It's like you've explained it. Okay, people understand it. You don't need an advanced degree. Actually, it is understandable enough. Well, if you don't need an advanced degree, then how useful you are, how needed you are as an educator goes down. So I think there's a natural tendency, and this is sort of, I think of this as the infinite library. It's like you go into the university and you see the stacks heading off, endlessly in all directions. And you're like, wow, it's impossible to ever know. And it's like, yep, that's designed to make it so that that helps to solidify the position of the researcher education business model, to put it that way. It's an interesting question how things should be funded, but I think that that's all gone too far, and that we should really, really be working to reduce the size of technical specialties. Like the way you would do this is by figuring out how to translate more and more of it out to the point that people could actually understand the things. The more you manage to train, it's not like you're cutting information out, you're figuring out how to bridge between regular people and the actual science. And so I think that's a possible thing. I think it's not an easy thing to do, but I've had great luck in conversations with scientists where they say something, I do not know what they're saying, and then I say, okay, so you're saying it's like a sponge. And they're like, yeah. And I'm like, okay. But is it not a sponge? Am I wrong? Can you like, they're like, well, okay, it's not exactly a sponge. I'm like, okay, so is it like a sponge with a hard core? And they're like, okay, that actually is a pretty good metaphor. And I'm like, okay, great. I just think it is possible to bridge the gap, at least way more than people have, between what is commonly understood, what we all can discuss here, not being experts in all the different fields, and the technical disciplines themselves.
So this is related to so many things. Shiloh has multiple times pointed out that is it the equations of fluid dynamics that are universal across all these different phenomena?
If you just go to the transport phenomena Wikipedia page, you'll see these. It's like diffusion, heat flow. There's a bunch of them. They're all congruent, though.
So there's a bunch of natural phenomena that can be described by the same mathematics, which implies that if you're trying to simplify some kind of phenomenon to something that is more intuitive, if they're mathematically congruent, then it's possible to actually make the analogy and have it be accurate.
Yeah.
And so I think that that's really valuable, where you're like, it's not quite the sponge because they're thinking almost mathematically about like, well, there's this other modulus that's in there, and then you stick the backbone to it, and they're like, yes, okay, great.
Right.
So I think that that's really useful. I think being able to put things into lenses that people can understand and you do something with is really useful. Like you were saying earlier that perhaps having a really, really extensive STEM education is detrimental to your ability to do something weird and crazy in STEM. And it might be because at some point you've memorized so many things that you've lost your ability to be creative because you're overfitting the data. You're like, this is how it is. I know all of these answers already. And so, okay, great. My thought about the start at the technology and work backwards is now that inherently lends itself to cloistering, because usually when somebody's trying to develop a technology, they're doing it inside of a market-driven system where they want to be able to figure out how to optimize it to the next level, and they want to be able to maintain that knowledge for themselves. And so you can't really depend on it being a technology back process of figuring out, because if Philips figures out how to build the first quantum computer, they're not going to tell you. They're like, that's going to be under 10 layers of NDA for the next 100 years, plus protected by patents and everything else to make sure nobody else can touch it.
There's a lot of scarcity mindset going on here that's creeping into the cracks of the standard institutional models, right? It's like, I think that a lot of that initiation that you hinted at it a little bit, I can't remember the exact words you used, but you're like, do they really want to hand over the knowledge to you so easily? Or do you have to prove that you can sit in the classroom for a year and then you go to this 200 level course? And it's like, if I was going to design a cult, like a Scientology type thing, that's exactly how I would set it up. I'm like, all right, so you got to get through the first chamber and pay your respect to, the grand wizard at the, whatever the hell it is.
Yeah.
And then, but maybe by the time that you've put in $200,000 to this thing, and we've given you the paper that you need to get you in the door at this job that you want. Maybe I'll tell you,
you've gotten to wear your professor's Nobel medal for a minute.
Yeah, so you can park in his Nobel parking place at Berkeley. Have you seen those things?
Yeah.
Hilarious. Yeah, so there is this almost Machiavellian layer to the way that institutions seem to naturally arrange themselves that is protectionist, and I don't know how you get around that exactly, because you're right, you should be able to explain your scientific theory to your grandma, at least on a surface level. And if there's a part in it, like electron spin, that you don't understand, just say we don't understand it.
Yeah.
We don't know.
Yeah. Completely agree with that. Well, I think we mentioned Samo Borya earlier. He has a really good framework for thinking about institutions, and he's got this sort of framework called empire theory, where he talks about whether the institutions or the empires are expanding versus declining, and whether they're centralized versus decentralized. And I found it to be a useful framework, but essentially the way you would model a lot of the existing scientific institutions is as declining centralized. So if it's expanding, then you get a different set of dynamics. If it's declining, then if it's decentralized, parts break off and seek their own fortune. If it's declining centralized, it's like the center is trying to hold all the pieces in so that everything sort of goes down together. And but that way it's not necessarily conceived that way, but it's like they're not letting parts break off and do their own thing.
Isn't it interesting about the
Yeah.
mythological parallels between science as an institution that is going down the drain and taking everything with it, and the idea that, like, at the center of each galaxy, there's a massive black hole that's gobbling everything up that will devour the universe? Like, it just seems like there's multiple layers of mythological patterning that you start to see when you think about the stories that are being told, where they're like, this is how the universe works. And it is the one place where we have these sorts of stories.
And oh man, I'm going to need to think of a positive sort of astronomical sort of, companion myth or something. Because I think in the face of a declining centralized empire, the thing you do is you just build outside of it. It's you try not to fight, and maybe sometimes that's unavoidable, but usually in things like that, their focus is internal. And so, I mean, I have been just extremely encouraged by how easy it is to build outside. And by how easy, I don't mean this is very easy at all. I mean that. So, just as a simple example, so history of science research. It turns out there's an important thing that's missing from history of science research, and that is an accessible data set. So we're here talking about the history of science, and we each have a couple data points in our mind. I just finished, Kuhn's Structure of Scientific Revolutions, and he's mentioning, a bunch of different discoveries, but he's doing pretty shallow dives on each of them. Some of them we've actually checked out deeper dive style, and the details actually differ. You actually need to do a deep dive on each of the discoveries. And then it just turns out that no one has done this yet. So this is sort of a plug for my history of science research program. But if you actually count up how many major discoveries have there been in the history of science, we tried to estimate it. It's obviously lossy, but we think it's like between 200 and 300. That's actually, and obviously as you dial up or down what counts as major, you can get larger or smaller numbers. But history of electricity, it's like somewhere between 12 and 14 from Gilbert to Maxwell. And then there's magnetism and astronomy and geology and etc. It's not that many. And each case study takes, you want to do a case study on each. It takes, let's say, 6 months to a year. Well, let's say it's, a year each, and it's 200, cases. That's 200 person years. That sounds like a lot of person years, but not really. That's actually a really small number of person years. And it's been possible to find researchers. They're qualified. There are people both inside and outside academia that we've been able to employ. You can it is sort of shocking to me that this hasn't happened, just like here's the study on all of the major discoveries, with the main question being, how did it happen? Why did it happen now, as opposed to like, could it, and as far as you can, could it have happened faster? Like, what are the rate limiting steps? Like, what's the actual discovery? In one case, we found that people hadn't pinned what the actual discovery was. But it's like, what's the actual discovery? How did the person make it? It's like military history, except it's like with military history, you get these military history buffs who love to study previous battles just because you don't have a big data set. Every case is super important. So you want to learn everything you can from every actual conflict that has happened. Same thing's true in science, right? There aren't that many total discoveries. Each one is different in some way. You want to learn whatever lessons you can from it. Okay, great. But so we've had, I'd say basically no trouble finding qualified people to do it. No trouble with actually having them do the research. We also haven't had trouble getting it published in mainstream outlets. And we ourselves are, outside academia, so it's independent, but it's like entirely backwards compatible. It's very friendly. And so I think that the history of science is just like, there's this project getting the basic data set on successful science that just can be done. There's nothing stopping it, because you can just do it. Sometimes you need a bunch of money to build cool instruments. That's Clarice's case. That one, you need several $1 million to build the fancy instrument. But we may actually end up succeeding in raising that money, in which case that's another case where you can just build outside of the existing system and science continues.
What is the example of the discovery where you realized that the actual discovery hadn't been properly identified?
It's amazing. So it's Francis Hawksbee. And the reason it's amazing is that the Royal Society now has an award, which I think is called the Hawksbee Award. But it's for the unsung heroes of science. It's for the unrecognized people, the people who are doing the work in the background and, not being rewarded for it. So we looked into it because we're doing the whole history of electricity to start with, and turns out Hawksbee was not actually an unsung hero. He he was from a different social class than other people at the Royal Society. That didn't seem to pose a barrier. He was an instrument maker. He was funded to perform experiments. Everything seemed fine. He was recognized. He was also Newton's assistant. No problem in terms of recognition. But then, as we looked at modern scholarship on it, we found that people knew that he had done something important. And as far as we can tell, we got a paper that at some point we'll publish on this whenever that seems relevant. But they hadn't identified exactly what he did. So it did turn out that there was some weird paradoxical way in which he was an unsung hero. The thing he did was isolating electric light. So the tricky thing is that people had bumped into electric light. So you have this case of Boyle where he rubs a diamond and gets some light. There were other people who had come across the phenomenon of electric light. The problem was that there were all sorts of things that produced light. It's like bioluminescence, and there's regular fire, and you have these big lists of a big list of things that produce light. The thing Hawksbee did was he took existing air pumps, as the early vacuum chamber, made it better in such a way that it was possible to run experiments in it, created a vacuum, put electric materials like amber in it, and then rubbed them. And the thing you find is that the vacuum quenches or puts out regular fire, but it causes electric light to become brighter. And and because it's happening with substances that produce static electric attraction, when you rub them, this shows that there is that the electrical substances are themselves producing light, and the light is different from the light produced by regular fire. And so it's experimentally isolating electric light as its own phenomenon. That's the thing he did. That might seem like the tiniest detail, but it's super weird if you have a data set and you're like, this guy was important, and you've like got a fuzzy circle around what he did instead of a sharp circle.
I mean, it's a crazy question to start to figure out where these lines of scientific realization boil down to. And I'm surprised that it's not more frequent that you stumble on something where you start to dig and you're like, that's fucking weird.
Seems like this would be really useful in the service of addressing, who was it? Was it Austin who was talking about the NIH panel that was unable to determine which research projects would be successful compared to mere chance?
Keon, who was at the patron chat, he pulled up the study. Where
one
it
of our
was like
patrons.
the ability of the NIH to predictively fund research that would lead to publications was almost non-existent.
Well, they judge the success of the research.
Publications.
No, lead to publications that get cited often. That's how they measure success. That's how they measure the success of a project.
And so they were basically,
I believe that.
worse
I believe that. Yeah, I believe that.
No, they're like, we could just throw a dart at a wall and like that would work just as well. But we put all this effort into triaging these and trying to,
In a lot of cases, what's happening is that the panels at NSF, NIH, or the decision makers are frequently relying on expert judgment from academia. So you have judgments being outsourced, and then I think specialization is a serious problem. It's you have specialization plus everyone feels like there is a scarcity of funding. There may actually be, but at least people feel like there is. And this causes people to develop these sort of like quasi-advocate positions where it's not just that they're a scientist who happens to be investigating X, and now it's that they're an advocate for X, and that means they're tacitly an advocate for not the things that might get, the other things that might compete with X. And so, and then I haven't worked out the picture here fully. There's some way this relates to the peer review phenomenon. So we all know peer review is having issues. Scientists aren't super motivated to do it. They frequently give peer review is frequently, at least people report, it's do I agree with your thing rather than is this science well done. I haven't pinned this down, but I think there's something like the scarcity of funding plus specialization is making it so that people don't end up being super good judges of everybody else's work.
I came across a really terrifying AI tool recently called Consensus. And it is
in a Professor Dave video.
Yeah, he's advertising this for those who know the glory that is Professor Dave. It is an AI tool that allows you to query the scientific literature, and it tells you what you should believe on the basis of what is consensus. Like, it tells you what consensus is in the literature for a given question, and it's marketed as basically a way for you to be able to appropriately shape your beliefs.
Is it just called consent? Okay, yeah, I think I found it.
I think there's like I think this scarcity mindset is a real pollution in the whole world in general. But I think we could narrow it down to academia and ideas as well. Like, I see people who, they have a cool idea and they devote the rest of their career to prosecuting that idea. And I feel like that sort of behavior is driven by this belief that having cool ideas is a rare and scarce thing. Like, I think I've also met incredible people who are they'll just throw out really crazy cool ideas all the time, and they won't prosecute them and try to convince you of them. Right. They'll just say stuff and move on. And like, those are my favorite types of people. But I feel like academia selects for the people who are willing to, play that game and just dig their teeth in and hold on to this thing and just march it through 40 years of a career publishing incremental pieces on it and so on and so forth.
Well, you're saying that academia doesn't have those people, or
Yeah.
that's interesting. Yeah, I'd love to understand better what the, because this was one of the we were trying to figure out why haven't people done this history of science project I described, right? It just seems like, imagine if there was this nice little index of 200 or 300 discoveries where you could read a nice synopsis, and then there's also this nice long paper in case you want to learn more that tells you, you're like, okay, please tell me what actually happened with Maxwell, and the answer is blah. The and one of the answers that we came to was that academic freedom, which is good in a bunch of ways, essentially allows people to follow winding paths as opposed to staying on one thing for 40 years, like you're describing. This is one of the reasons that I'm such a fan of focused research organizations. If you've heard this term, but this is a thing that's being experimented with now. It's like there's a couple different formats, but essentially it's sort of a hybrid between a startup and an academic group and some other things. But essentially it's mission driven, and it isn't necessarily aiming for publications in the short run, but there is some goal that it's aiming at. I think that that's like a really good way to do it. And you could imagine it's like, if you have 10 people, each of whom do a case study, say we get the process a bit more efficient, it's 6 months each, they do 2 per year. Cool. It takes 10 people 10 years to do 200. Then, well, that actually, then you produce this thing that's of like really substantial public value. And I don't think that doesn't happen naturally inside an environment where you have essentially lots of researcher freedom. Obviously, researcher freedom, again, is good for a bunch of things, but I like the focused projects.
I
I
also
like that.
wonder if it isn't partially because science has been working relatively well for a relatively long time. And I think that when things work well and you're able to make technological gains, and every decade seems to be like you're better off than the previous one, it's like, why spend all this effort figuring out what it takes to make really fantastic science? Like, you're living in the spoils of it. And so there's a really strong tendency to not overanalyze when things work. And it's only when things start to break down and people start to look around. Because, like, I don't think we could have
Yeah.
had this conversation 40 years ago.
Yeah.
Like, not even necessarily because of the technological limitations. I just think
Sure.
that people would have laughed you out of the room. They're like, science is great. Science is doing just fine.
Well, but this gets to the point about the change in science after World War II, where I think about it as a big experiment. It's, you have the atomic bomb, Manhattan Project, then you have Sputnik. Okay, fine. We want to scale up science. Then science gets scaled up. I think it's like 40 years ago, it's like we're in the 80s. I think the experiment was still a little too early.
I mean, a ton of
But
biology was coming through in the 80s, right? It was molecular cloning, it was figuring out all of these, the ability to take the insulin gene and put it into yeast to like vat produce medicines. Like, all of this stuff was still, like, biology was exploding in the 80s because it was the first time that we actually had like modern techniques to actually be able to do the kind of industrial biochemistry that we just take for granted today, I think.
this makes me wonder how fast we want science to go. Because when I think of that, I then think, well, couldn't we have that occurring in all the fields at the same time? And then I think that, wow, that would be that would be crazy. Does society actually have the ability to absorb that amount?
I don't think it
It's
does. I really,
well,
really, really actually think that it does not. And I think that if you think about what happens to us after the atom bomb, I think
right.
what happens to us after like Roundup Ready crops, what happens to us after the invention of radio and television,
Yeah.
I think we're still like way far from being able to figure it out. And I don't know, maybe this is actually a good place to rest on this question of like, how fast should we be going? We're preoccupied with, well, we should be going fast. Clearly there's ways to optimize how fast we go. And then there is also in the back room this question of like, well, hold on a second. What happens to us when we go fast? Do we know?
I mean, you want your institutions to be sort of slow moving in some sense. I mean, that's why government is impossible to get anything done in too. It's like, well, yeah, but that's kind of nice also because you don't have to like expect a completely new form of government every morning when you wake up. And it's like, that's nice. And I understand that that's why we lean on institutions, because they're dependable in that sort of slow, oafish way. But man, I wanted to, we didn't even get to talk about some of your other work too, because I really was interested in talking to you about the psychology stuff. But we've almost done 3 hours here, so I don't know. Maybe we'll have the chance to talk again.
Sure.
Down the line.
This has been a great conversation. I think the pace question, I think, is a really, really good one. I think there's a slogan that a bunch of my team and I always had, which is go slow to go fast. Like the reason you'd want things to go slower is so they don't jam up or explode or be bad for people, because you actually want it to go fast. So it's like, we do want it to go fast, but that doesn't mean you make all the parts of it go fast. You want to find what's the rate that human society, what's the rate that we as people can actually absorb scientific and technological change. And I don't yet know the answer to that, but I don't know. It's a great place to rest the conversation.
I think it terminates on the tiptoeing the line of order and chaos, which has been like a mythological, it's like the foundational mythological cosmology of almost every single culture going all the way back. It's like, even in your own life, right? Like you can get over ordered. A government can become over structured, and then it starts resembling some fascist totalitarian hellscape. But you can also be overly chaotic, right? And then, you're just tripping over your clothes trying to get dressed in the morning or whatever it is, right? But so striking that balance seems to be critical, and it's not an easy task. But anyways, I'm cracking open cans of worms, so we don't have time to finish. So.
I think that we should put this conversation out and then see how it plays. And if people enjoy it, then we should plan to have another one, because there's a lot left here. I want to say thank you for taking the time. I know that 3 hours is a big block, especially on a Sunday afternoon, and I really appreciate it. And for putting us in touch with, is it James Sinka?
James Sinka, yeah.
Yeah. So he's going to help us figure out, he's going to convince us that crypto is a good application for long-term projects. And then we've got Clarice coming, and so it's going to be really good to get the whole picture of this. So I appreciate you kicking it off.
Before we let you go, people want to learn more about your work. What's the best way to read about you and maybe get in contact, anything like that?
So for contact, people can just check out my Twitter handles at Geoff Anders and send me a message. For my work, leverage.institute. That's we got a new website coming up in ideally the next couple days, actually. But we're really trying to, essentially, it's research projects or research programs that pick out areas in science and technology that we think are stuck, we think can be unstuck. History of science is one. Mentioned psychology. We've been helping Clarice with quantum biology. But the bigger vision is that there's all of this great stuff out there that can be discovered, that is being discovered. And we want to help people understand it, and we want to push the things forward at the right pace.
I love it. Yeah, that's what we need. We need those parallel bridges before we rip down the old ones.
Absolutely. And hey, we're in the Bay probably like 5 or 6 times a year, so we might hit you up the next time we come down, grab a cup of coffee.
I actually live on the East Coast.
Whoops, that won't work out.
Interesting. For some reason, I thought you were based in the Bay.
I was,
I see.
and yeah, and my organization Leverage was based in the Bay from 2013 through 2022, I guess.
I see.
But yeah, no, now in the East Coast. But
We never go
let's,
back there.
yeah, well, let's stay in touch. Maybe physical paths will cross.
Okay, very cool. All right, thanks a lot, Geoff.
All right, see you guys.
Bye.
Bye, everybody.